In this video, I want to show how to gather a clocking angle from a step file and then measure that to compare if it is in the right location or not. So the first thing we're going to do is collect the straights from cylinder surface using that first option in our collect control. We're going to rebuild, then we're going to grab the end trim from a surface solid. In this case, it's the face of the flange. Now I'm going to scroll all the way to the bottom until I see cylinder drill surface. I'm going to grab 1/2 of the drill surface, and then I can right click, left click, and right click to add. I'm going to rebuild this tube, and then I'm going to rebuild all drill bit bosses from collected cylinder drills. This puts some information in the constructed features. I'm going to right click, I'm going to create a circle from a drill bit boss, and I'm going to perform a test first to make sure that the arrow is pointing in the right direction. If it's not, you can always flip the other end of the direction using just the other side of the boss or flipping the nominal direction. You can test this until you have it in the correct orientation, and when you do, you can then switch from a test to a space object. Create new space object from the current test build. Now, if I hit this blue arrow twice, you can see what it's going to be linking to. So I need to link this to the first straight, and you can see that this has an angle of 164.84. So in relation to the next bend plane, that is the clocking angle. Now this is a positive number because counterclockwise is positive and clockwise is negative. Okay, so in relation to this bend plane, if I were to go all the way around, it would be a positive counterclockwise. So this would be about 180. This is a little bit less than 180, 164. Okay, so positive rotations and negative rotations. Now we're all set inside VTube Step, so we can close all the floating windows and switch to VTube-LASER. Now that we're in VTube-LASER, the first thing that we're going to do is measure the tube. So using Quick Start or Uniscan, I'm going to measure this tube. Starting with the face of the flange or the tube itself as end A. I'm going to measure straight 1, measure straight 2, and end B. Now that that's complete, I'm going to finish and build measured tube, and I'm going to align the measured to master tube. Once that's complete, I'm going to change the coordinate system from ARMCS to measured aligned tube and toggle the laser so the bar turns black. That's showing me then that I'm in ball probe mode. Next, I'm going to measure a circle with the ball probe. Inside the circle on the flange, I'm going to take 3 points on the actual circle and a 4th additional point in the center of the circle. Once that's complete, I'm going to hit accept on the arm, and VTube is going to prompt me to measure a plane. So 3 points on a plane, so 3 points on the face of the flange, and a 4th directional point, and press accept. Once that's complete, I'm going to hit test, and you can see that the wrong hole was measured, or in this case, simulating that it's not in the correct location. So I build the test, and then I'm going to build existing, and I'm going to snap what I measured to the step file hole location that we gathered inside VTube Step. Once that's complete, I can go to Space Objects, Show Space Object Control, hit the blue arrow twice, and this will show you what the nominal is, 168.84, what was actually measured, and what the deviation is. In this case, negative 247. So you can tell right away that this is in the wrong location. I would need to make a correction either positive counterclockwise or negative clockwise in order to get this in the correct location. Now, of course, it depends on your tolerance. If you had a really small tolerance of 0.05, this would, of course, not fit the spec. Once I hit report, if I go to the Space Objects report, it will show up as 2 individual lines. Whatever you select inside the Space Object Control list will appear here on this report. You can rename the circle, the test, and that will show up on the report as well. Now let's simulate if this was in the correct spot. So once you've moved the flange to the correct location, or a more correct location, you can then build a test, and you can see that this is much closer. Not quite directly on, but it is much closer than the previous one. I'm going to build existing, insert into existing circle. I'm going to go to space objects, and I'm going to look at that information now that we've remeasured it. We've moved the flange and remeasured. You can see here that it is much closer, and if a tolerance of half a degree, 0.5, then this part would more than fit within the tolerance. Once you report on that, this is complete.